Alright, so now I'm going to show you how to determine if the data is parametric, and this will probably be broken up into a few different videos, but remember, if we look over here on the PowerPoint slides, the criteria for determining if the data is parametric is one, it has to be measured on an interval scale, so I'm going to kind of put those parameters here. So this is the length of Adelia bipunctata. I believe that's some type of shell or clam or something like that, I'm not sure, but it's in millimeters, so length, it tends to be continuous. This is a quantitative data, and it is rankable, lengths are rankable, so that data is interval, so I will just kind of go over here and just put yes, it's continuous, rankable, and quantitative. So that parameter is good to go. So now we need to figure out if it has a bell-shaped curve. And that one's a little bit harder. I'm going to jump ahead real quick to the skewness parameter because I've already showed you that. So I'm just going to fly through just some quick reminders here. So I'm just going to get the averages equals average. I'm going to select my data here. Equals standard deviation, need the standard deviation. And remember sample, because we don't have the whole entire population measured here. Alright, so what's my count? How many data points do I have? Because that's going to determine my maximum skewness value allowed. So equals count. Type it in. And so now my SES is equal to the square root of 6 over that count. And my maximum allowable skewness is equal to 2 times that. Remember, you have to type in the equal sign every time you're making it do a calculation. So there's my maximum skewness parameter. So what is my actual skewness? Well, for that I need to get the descriptive statistics. All right, and so that will be this data here. There's my data. Don't include any of my calculated values there, just the data replicates. I keep forgetting the labels. Good thing to remember. Labels in the first row. I need my output range, so I am going to set this up to show the data there. I have my summary statistic clicked, and there we go. And I see my skewness is actually negative 0.09, so the absolute value of that, 0.09, is indeed less than my maximum skewness, which was 0.69. That value is just from my 2x SES. So basically this data says yes, it does fit that skewness parameter. Alright, so if you need more help with that, go back to the skewness video. That was just a real quick reminder on how to do that. Now, let's jump to the whole idea of, does the data look like it has a bell-shaped curve? Alright, so remember, this is continuous data, so in order to create our graph, our bell-shaped curve, if you will, we need to find bins, and these bins need to have equal ranges within the bin. So in other words, you can't have one bin that's anything from 2 to 5, and another bin that's from 5 to 10, and another bin that's from 10 to 100. All right, if your range is 2, from 0 to 2, well then your other ranges need to also be 2, 2 to 4, 4 to 6, 6 to 8. All right, this is probably the hardest part of this, is trying to figure out how many bins to make and how to make your bins. In general, we want about 5 to 10 different bins. All right, most data is probably going to range somewhere between 10 and 50 values. And so if you're on the low end, 10 can be tough. If you're on the low end of that range, you want to only make about 5 bins. If you're on the high end, you might want to make 10. If your data has a ton of data, you can make even more bins. But what you're trying not to do is make the data just basically have one big large peak. That's too few bins. But you also don't want to make the data just have one value in each of those bins, because then you have too many bins. So in general, think about 5 to 10 bins. 5 bins is good, the max kind of for values that are between 10 and 20. Here we have 50 data points, so it was okay to go ahead and kind of create about 10 different bins. But then we need to figure out the range. Alright, so this is where my descriptive statistics can come in. It tells me my minimum data point and my maximum data point. So whatever you do, your bins have to span that range. Alright? So my range here, I'm just going to make it easy on myself, and I'm going to call that range anything from 0 to 10. So my range is 10, right? And I need my bins. I want about 10 bins, so that's easy. I'm going to have each bin be a value of 1. Alright, so the range 0 to 0.9 falls in one bin. 1 to 1.9 falls in the next bin. 2 to 2.9 in the next one. I've created my bins here so that I have 10, and they're all equal, and they cover the minimum and the maximum in the range. Alright? Now, what do we do with this? So, this is kind of where this, you have to know what Excel is doing when you create bins. So, these are the ranges. Alright? This is going to be great for graphing labels, or sorry, labeling the x-axis on the graph, but Excel can't use this. They need a syntax. So for Excel, you are actually going to type in the highest number of that bin. 0.9 is the highest value of that bin. What this means is Excel is going to say anything below 0.9 will go in this bin. Right? This is why we need to make sure we have our bins cover the range, because let's say I started my bins at 4.9. If the very first value I had was 4.9 and I just kind of worked from there, anything under 4.9 is all going to go in this bin, and they're no longer equal. So you need to make sure your range covers, your bin's range covers all of the data points, the values that you have here, the minimum and maximum. Alright, so anyway, I'm just going to type 0.9. My next one I'll type 1.9. Basically this means that anything above 0.9 up to 1.9 is going to go there. And then 2.9 here, so anything from 1.9 to 2.9 will go there. Oops. I don't want 3.0, 3.9. I'm basically just starting to put in the bins. Basically, since Excel does not work with ranges, it needs a specific value. This is telling Excel what my bins are. Every bin is basically from the previous value to that value, right? And it includes this. So if I have a bin of 0.9, that's going to be through 0.9. That means 1 will go here. If I had a bin of 1, so if I did my bins, if I put a bin of 1.0 here, what that would mean is that 1.0 is included in that. And that means this bin wouldn't start until 1.1. So I need to remember to put the highest value of each bin in there. And don't make your bin 0 to 1 and then 1 to 2, right? Because you can't have a value of 1 be in both of them. All right, so that's the bins. Think about that for a little bit and kind of work with it, but that's how you set up these values here. Now, how do we get Excel? All right, so let's jump back over here. So here are our bins. This is kind of what I showed you here. How do we get Excel to give us the frequency? We want Excel basically to tell us how many data points fall within 0 to 0.9. How many data points fall within 1 to 1.9? How many data points fall within 2 to 2.9? All right, so what we're going to do is we're going to type equals frequency, and you'll see it pop up. All right. This right here is going to be your best friend for remembering how to do this. So I've typed in frequency. Now I need to, and it actually tells you here, I need to select my data array. So I need to select my data. This is the whole range. So I've selected my data, and then I need to type in a comma. If I go back up here, now it's asking for my bins array. This is the bins array. Oops. Do not use the ranges here because it won't know what that means. This is why we had to type these up this way so that Excel can use that data as the bins. All right. Now I'm going to hit enter, and I'm going to get that data in the top range. All right, so once again, what I have is frequency. I typed in equals frequency, double-clicked on that function. I selected the range that my data is in, and then comma, and then the bins range. All right, and then just enter. Now you'll see that it just gives me one thing here. This is telling me that there's one data point that falls within 0 to 0.9, and it's actually this one right at top here. There are no others, so that's why it told me I have a frequency of 1 in that bin. But how do I get that to the rest of them? All right, so now I'm going to then just go like this, copy the whole area where I want those bins, and this is what you need to kind of remember here. This is not intuitive. I don't know how Excel came up with this, but this is what you have to type in. All right, you're going to hit F2. So on your keyboard, you're going to hit F2 and let go, and you'll see it's okay saying, oh yeah, I know you want me to do something with this frequency. And then you're going to hit Control, Shift, Enter. Hold all three of those down at the same time. Hold Control and Shift, then hit Enter, and it is going to populate the rest of those with your frequencies. All right? And at this point, we can now create a graph. So if I select my data points, oops, if I select my frequencies, I can insert a bar graph. All right, there's my bar graph. And now, if you want to label these things, I can just right-click on this and select data. One of the great things about right-clicking and select data is I can give it my x-axis values. Just select those, and those ranges will come in here. Right, so make this a little bit bigger. Make this a little bit larger with the font. And obviously now I would need to label my axes. All right, so if I label my axes, I can go to Add Chart Element. So if I add the chart element, then that's where I can create my axis titles, primary, vertical. I can just kind of label this. My y-axis is the frequency. Basically just kind of make this look nice. But what you can see here is that I have a pretty decent bell-shaped curve. I have a pretty decent bell-shaped curve here. So I can say that within reason, I remember I don't have unlimited data, so that's how I do that. Right? I just wanted to show you what happens if I kind of did my range differently. So 0 to 1. So if I have this range, I would need the bin of 1, and then 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is perfectly fine because they're still the same range, but now any value of 1 is going to go in this one, whereas here the value of 1 went in my second bin, and so forth. So this just kind of gives us something different. If I use these bins, I can still get my frequency. I'm going to type equals frequency, double click, select the data, comma, then go back, select the bins, that's my new bins range, hit enter, and select the whole area there, F2, then Control, Shift, Enter, and you still see that it looks like a pretty good bell-shaped curve, but the data's fallen a little bit differently because we created our bins slightly differently. Either of these are fine, but that's how you create a graph to see if your data looks bell-shaped. Now this is one of those parameters that you have to decide within reason. All right, there's going to be some that are pretty obviously not bell-shaped curve, but there are some that you might have to use a little imagination to imagine it's bell-shaped. This is why we have 5 parameters. So if you have one that's kind of iffy on that, you're not sure, but it fits all the rest of them, you're probably okay. If you have one that's kind of iffy on the bell-shaped curve, and a couple of these other ones also don't hit the parameters, that's probably not parametric data.